So once again, just as a quick review, and then we had the proportion. And then after the proportion, we talked about percents, which usually is 2 words, but here we say that it's 1, and that's okay. A percent means that it's out of 100. So in the ratios and the proportions, which we use as fractions, we should have a denominator because it's the percent. The denominator is 100 on that stuff. Okay. Now last time we also talked about the proportional constant. As it turns out, the proportional constant is usually what they call a unit rate. And the proportional constant, we didn't really address this last time, but for the most part we saw these proportional constants as one of the values. Whether it be, I guess we didn't talk about x and y's, but one of the values has to be a 1 with the two things that we're comparing. So like last time when we talked about sunflowers and roses, maybe we were comparing it, roses to 1 sunflower, or sometimes we can compare sunflowers to 1 rose. Okay, it doesn't really matter how we compare it, but that constant can be used using multiplication or division to find other values. And the unit rate works the same way. So the nice thing about this is, since one of the values is a 1, all we got to do is scale the 1 to be whichever value we need it to be, so that we can find the other missing value that we're trying to find, right? So like last time, for example, when we looked at Roman in his car, he was going 30 miles for every 1 gallon, right? So that was the proportional constant, 30 miles per gallon, which is also the unit rate, because see how one of the values is a 1 right account? So, since one of the values is a 1, we can scale this, for example, and last time we said, well, how many miles can he go with 8 gallons? You guys remember that problem? Hopefully. So what did we do? We did 1 times the 8 to get the 8 gallons, and we did 30 times the 8 to get 240 miles. So that tells us right there that he can go 240 miles with 8 gallons. It is possible just to use a rate and then scale that up, depending on what we're looking at, okay? So it's and preference. So it depends on what you like as to how you want to do it. So this first activity, right account, we got to fill out this missing information. So let's take a look at this first table. So right here we have 48 hours for 60 miles. So how many miles would we go in 7 hours? Well, the question is, and we can write this as a fraction down here. So which do you want in the numerator, miles or hours? Miles? Hours? It's up to you. Miles? Okay. So we'll put miles in the numerator and then hours in the denominator. So the one it gives us is 60 miles for 48 hours, right? It's just like the tables that were on the homework. And what we want is to know how many miles for 7 hours. So how do we change the 48 into a 7? Yeah? Well, we got to figure out, yeah.
Can you do like the 60 times 7 divided by 48?
Okay, so you're getting a little ahead, but yes. Yes, you can. So if you guys are doing it that way, that's all right. Now, so far we've been using the method that we call scale factors, where we just multiply or divide the numerator and denominator of one fraction by something, the same thing, in order to get the new fraction. All right, so for example, right account, 48, we want to divide this by something to get 7, so that it becomes smaller. Well, what do we divide it by? Well, in order to find that, we will do... Actually, I'm going to change that to multiplication, just because this one's a fraction. So, for example, to figure out what we would multiply 48 by, and we talked about this last time, right? We'd do 48 divided by 7, which if I did this in a calculator, so 6.87, so I would multiply this 48 by So as it turns out, I would multiply the 7 by that 6.86 to get the 48. So the question is, right, it's kind of like solving an equation, right, Cal? Multiply the x by 6.86, and then I get the 60. So how would I figure out what that is? Well, I just need to change this to division. 60 divided by 6.86 would tell me how many miles that is. So it looks like it'd be 8.75 miles. That was kind of a pain in the rear, right? Because, well,
Would you do fractions or not fractions?
you could do fractions. I'm okay with the decimal on this one. Just because it kind of sets up really weird. But the nice thing is, this one, and it doesn't matter, we don't really like the mixed numbers, right? So we could change this to 5/4. Alright, so this one, this is actually the same rate as it turns out. But now we're comparing this with 1 hours. So if we look at the same ratio in miles to hours, then we can see that we'll go 1.25 miles in 1 hour. But this should equal some number of miles in 7 hours. Well, how would we figure this out? We'd do 1 times the 7 to get to 7. See how that makes that pretty easy? And then the 1.25 times 7, which would be
35 over 4.
35 over 4,
Yeah, or 8.
or 8.75. Yeah, very good. Now notice, we got the same answer for both of these, right? The 8.75. But one of these was much easier to solve, right? Why? Well, no, there were fractions, lots of fractions.
No mixed numbers.
There was no mixed numbers.
Wait.
Which one was easier, the first one or the second one? Well, hopefully the second one was easier. Because what did we do? We saw that to get from 1 hour to 7 hours, we just had to multiply that by 7, right? And then we multiplied, you could multiply the fraction as well, 5/4 times 7, and get the 35/4, which is 8.75, okay? So it just doesn't matter which way you look at it. But one way should hopefully seem a little bit easier. Now why is that? Well, this one has a 1, so what kind of rate is that? Remember we talked about it at the beginning? Yeah, it's a unit rate. Very good. All right, so we got John. He's walking at a constant rate of 8 miles every 3 hours, right? So what is the rate? Not the unit rate, just the rate. What is the rate in miles per hour? So how many miles did he go?
8.
8 miles. In how many hours? 3. Now we can find the unit rate, though. And it asks us for a specific unit rate in miles per hour, all right? So if we wanted to scale this, right, we started with 8 miles to 3 hours. And this should equal some number of miles in 1 hour. So how many miles is that? Well, what would we do to get the 3 to be a 1? Divided by 3. And so what would we do to the 8 miles? Divided by 3. And what do we get?
2.6 repeating.
2.6 repeating. So I'm going to write this one as a fraction, okay? So that would be 8/3. So this is how we can find the unit rate. Notice all we did is we took the 3 hours and divided that by 3 to get the 1 hour. Okay, but again, if we do it to one of these values, we got to do it to the other one as well, okay? So that is how we would find the unit rate. Then we need to know how far John can walk in 5 hours. Yeah, good, yeah. So 13.3 repeating or 40/3. Let's look at how we get that, right? So I'm going to go back to the unit rate on this, which we already saw is 8/3 miles for every 1 hour, right? And this needs to equal some number of miles for 5 hours. So how do we get that 40/3 or 13.3 repeating?
5 times 8 divided by 9.
Very good, yep. So 1 hour times 5 would give us the 5, that's in hours right there. would give us the 5 hours. So 8/3 times 5. If you want to do a fraction multiplication, that would be okay. 40/3 miles, or 13.3 repeating miles, right? In 5 hours. Alright, so let's fill in this table. Let's say that old John, he's going to walk for 0 hours. Then how many miles will he go? 0, because he hasn't walked at all, right? Right? And we already did this one. If he walks for 1 hour, how many miles will he go?
Should we do fractions or 8/3?
I'm just going to do the fraction. I think that'd be easier for me. But if you want the decimal, that's fine. So yeah, we saw that it was 8/3, right?
3 was probably
So if I wanted to know how many miles he can go for 2 hours, right? We're just going to take the 8/3 times 2, which would give us 16/3. Right? And then if I wanted to figure out for 3 miles, I know it's 8/3 every 1 hour, then multiply it by 3 hours. So this would be 24/3. But I could simplify this, right? To be 8 miles. That one was pretty easy to simplify right there. And the same thing for the rest of the D. It's going to skip right here from 6 to 10, so just be careful on that one. Alright, this last part is where we kind of run into problems, because now we got H hours. So how are we figuring out how many miles he was going? Well, you can see right there from the work that we've shown, it's just 8/3 times what? H, which is the number of hours. So on this one, it's always going to be 8/3, which was our unit rate, times the number of hours. And that will tell us how many miles John has walked. So where in the table do we find the unit rate though?
number 1.
Yeah, where one of them is 1. Specifically for this one, it was miles per hour. That should be this one right now. Alright, suppose it takes Nikki 4 hours to go 9 miles. Is that proportional to John's rate? Well, John, we can see he went 4 miles. Oh, it's a little bit big. He went 4 miles in how many hours?
Are we skipping that? Which one?
4 hours. I'm sorry, 4 hours. So this needs to be equal to Nikki's, and that's hours right there, which is 4 hours and 9 miles, right? Are these equal? No, because if we change John's into a decimal, we should get something like 10.6 repeat. So knowing this, we can see that they're not equal. So this is not proportional. But who's walking faster, Radical?
John.
John is, right? Because John's walking 10.6 miles every 4 hours, while Nikki's only walking 9. Alright, for this one, we're going to write the unit rate for each given situation. Make sure to include units of measure in your answers. So, for all the problems, there's usually one unit rate that makes sense, even though there's 2 different unit rates. And for this one, we'll look at both. But there's one that should make a little bit more sense than the others. For example, on this one, the sandwich shop uses 24 slices of meat for every 6 sandwiches. So on this one, we'll make our ratio. And what 2 things are we comparing, Radical? Well, those are the values. Well, hold on, though. What 2 things are we comparing, though?
Slices and sandwiches.
Slices and sandwiches, right? So we got slices and then sandwiches. Now, you could have switched these 2, okay? So you could have had sandwiches in the numerator. It's not going to matter. But we can see the one that they gave us was 24 slice for 6 sandwiches, right? Now, we want the unit rate on these. So would we want to figure out how many sandwiches for 1 slice or how many slices for 1 sandwich?
How many slices for one sandwich?
Probably how many slices for 1 sandwich, okay? So, how do we do that? Because we want 1 sandwich on these. And then we got slices. Yeah, we got the 6. We'd have to divide that by 6 to get the 1. So 24 divided by 6 is 4 slices every 1 sandwich, okay? Now, if by chance we did want to figure out how many sandwiches for one slice, how would we do that? Well, at this point, we'd get to do 4 divided by 4 to get the 1 slice. And then 1 divided by 4 to get either 0.25 or 1/4. So in other words, if I have 1 slice of meat, how many sandwiches can I make? 1/4. There we go. So as it turns out, there are 2 unit rates right here, but only one of them should make a little bit. Let me take that back. One of these should make a little bit more sense than the other one. Okay. Which one does make some more sense to you guys? Yeah, 4/1. Now it is nice to have both of these, just in case they ask us, for example, if I had 9 slices, how many sandwiches could I make? Well, then I would multiply the 1 slice by 9 and the 1/4 by 9, and I could see how many sandwiches I could make with 9 slices of meat. Okay. Now the model, will say that the model is the proportion radical. Determine how many slices of meat you'll need for 5 sandwiches. Okay, that's a good one. Well, which unit rate would we use?
The 1/4.
Yeah. I guess we wrote it as 4/1 though, right? 4 slices to 1 sandwich. I'll put it on my desk, please. And what we want is to know how many sandwiches. No, yeah, I'm sorry. Yeah, we'll use 4 slices for 1 sandwich because we know that it's going to be 5 sandwiches. See, and that makes it a lot easier to scale this 1. I just multiplied by 5 to get my 5 sandwich. So 4 times 5, how many slices? 20. 20 slices. Now B, though, is asking how many sandwiches can we make with 15 slices. So we're going to have to use that other unit rate because we have 1 slice in that. We're going to compare this to 15 slices. And we'll figure out how many sandwiches. Now again, it doesn't matter if you use the decimal or the fraction on these. But how do I take 1 slice and turn it into 15 slices? We'll multiply it by 15. And I got 15 slices, right? But if I do it to 1, I got to do it the other. So 1/4 times the 15. I'll just say 15/4 sandwiches. I mean, yeah, if you put 3.75, that's okay too. It took 3/4 of a cake to feed 1/3 of the class. Now again, the model will just use the proportion on these. So what 2 things are we comparing? We've got, very good, yeah, cake and class. Right? Well, right up there it told us it was 3/4 cake for 1/3 of a class. And let's find both of the unit rates for these. So for example, if I wanted to figure out for 1 class, what would I do with that 1/3? How do I change 1/3 into 1? Multiply it by 3, right? So I would multiply this by 3 to get the 1 class, and then I'd multiply the 3/4 by 3 to get 9/4 cake. Now that's one of the unit rates, right here, but it told us that it wanted a second possible unit rate, which means that we would need 1 cake. So how many or how much of a class could we feed with 1 cake? Well, how do I take 9/4 and make it a 1?
You mean a mixed number?
Or as a mixed number. Alright, well, here's what I would do. I would divide it by itself, 9/4, to get 1, okay? Because anything divided by itself is 1, right? And we're looking at, see how many classes this is. So what do I do with the 1? I divide it by 9/4. Well, 1 divided by 9/4 is the same as 1 times 4/9, which would give us 4/9. So 1 cake would feed 4/9 of a class And 9/4 of a cake would feed one full class. So how many cakes would we need to feed two classes? Yeah?
18/4.
Correct. Very good. Which unit rate would we use? Would we use the one class unit rate or the one cake unit rate? The one class. Very good. So right there we'd get 9/4 cakes to one class. And we want this to be two classes. So what do we do? Yeah, multiplied by 2. And that would be 18/4. But we should simplify that, right? This is cake. Simplify this to what?
2 and then 4.
9/2. Yeah. So we take 9/2 cakes to feed two classes. What percentage of the class will I feed? With one cake. Will one cake feed? So if I had one cake, I would feed 4/9 of the class, right? Now the problem for this is that I need to change this into hundredths. Okay. So what would I multiply the 9 by to get 100? Well, we'll do 100 divided by 9, so I can just say 100/9. Yeah, right, as the decimal. And you could use that. This one, we'll just multiply this by 109. So that's 400/9. Let me make that smaller. Okay, well, this one is the percentage, which should have given us 44.4 repeating. And that would be the percent. Well, it takes 3 3/4 of a cake to feed 1 2/3 of the class. Is this proportional? Let's find out. But we hate mixed numbers, so let's go ahead and change this as well. All right, and this should be equal to, which unit rate should we use on this one? Well, actually, let's make this one a unit rate. So on this one,
Wait,
that's better. All right, well, let's just make this a unit rate. So is I'm going to make the class, I'm going to compare it to one class. So to do that, for one class, I would divide this by 5/3. Because anything divided by itself is 1. So I'm going to divide this by 5/3. And I'll show the work over here. 15/4 divided by 5/3. Of course, you guys could use a calculator, right? 15/4 times 3/5. So simplifying these, it looks like we got 9/4. 9/4 cake. Well, how much of a cake could we? How much cake would we need to feed one class for the original? 9/4. So this one, is it proportional?
Yeah.
Yes, because this is an equivalent ratio with this one. All right, find a unit rate for each situation to answer the question. So let's figure out the unit rates for these. All right, well, Gene sells M&Ms to friends at 4 for 5 cents, but the machine at the store sells 9 for 25 cents. Which is the better deal? Well, let's figure out the unit rate. So Gene, for example, write it down. Gene is selling 4 M&Ms for 5 cents. Right? So to figure this out for 1 cent, we would divide the 5 by 5. So we'll take the 4 divided by 5 as well. So it's 4/5 M&Ms for 1 cent. Well, hold on. So that's the unit rate because one of the values is 1 right there. And then we got the store. So yeah, let's look at that. So it's 9 M&Ms at the store for 25 cents, right? And this would equal then because we want 1 cent so we can compare these. So we divided this by 25 and we get the 1 cent. And we'll divide the 9 M&Ms by 25 as well to get 9/25 M&Ms. Well, if we look at these as decimals, 4/5 would be 0.8 and 9/25 would be 0.36. Thank you. So, which is the better deal? Yeah? Why? Yeah, so as it turns out, Gene is going to give you more M&Ms for 1 cent, right? And yeah, if we compared these directly, we could scale the 4/5 up to be 20/25. So Gene will even give you more M&Ms for the same number of pennies, right there. So the better deal is Jean. Or Gene. Yeah, Gene would give you 20 for 25 cents. Very good. Frosted Flakes has 11 grams of sugar per ounce, and Raisin Bran has 13 grams of sugar per 1.4 ounces. Which cereal will taste more sugary? So we're looking for the more sugar for each gram, right? So let's look at Frosted Flakes first. Frosted Flakes has 11 grams for 1 ounce, because it's per 1 ounce right there. Well, that's the unit rate for Frosted Flakes. That's not too bad. But then we got good old Raisin Bran, right? Which is 13 grams for 1.4 ounces. Now what we want is to figure out how many grams it is for 1 ounce though, so we can compare them directly. So how would we get 1 ounce from this? Yeah, good. Divide 1/4 by 1.4 by 1.4. Which is 1. So 13 divided by 1.4 is 9.3 grams-ish. So which one will taste the most sugariness? Yeah, Frosted Flakes. In 9 minutes, Guillermo reads 7.5 pages of a novel. In 15 minutes, Courtney reads 18 pages of the same novel. Who is the slower reader? Alright, well let's look at old Guillermo first. And Guillermo is reading 7.5 pages. We'll just make that a decimal.
This is 15.
7.5 pages in 9 minutes. So how many pages can Guillermo read in 1 minute? Yeah, 7.5 divided by 9. Because we divide the 9 minutes by 9 as well, right? So what is that? 0.83 repeat on. Okay. Well, that's Guillermo. That's how many pages he reads in 1 minute. Now this one is asking who the slower reader is, so we got to be careful on that. But we got Courtney as well. And Courtney reads 18 pages in 15 minutes. Right? So then how many pages will Courtney read in 1 minute? Yeah, we'll divide that by 15, right? So 18 divided by 15, 1.2 pages per minute. So who is reading the slowestest? Tom sells baseball cards at 10 for 35 cents. Is that a better deal than 12 for 40 cents? Let's find out. Well, Tom, he's selling cards, 10 cards for 35 cents. So how many cards for 1 cent? Well, we'll divide that by 35, right?
Yes.
To get the 1 cent. So 10 divided by 35? Or not 30. Sorry,
0.2857143.
Well, just 0.29, yeah. Very good. Thanks for those decimals, though. And then, is it a better deal than 12 cards for 40 cents? Well, let's find out. So we need this to compare to 1 cent. How many cards would that be for 1 cent on these? Well, we'll divide both these by 40, right?
0.025.
0.025? 0.3. Okay, well, is Tom's a better deal then?
No.
Tom is not giving you as many cards for 1 cent though, right? So Tom is not giving you a better deal.
By 1.
The flight from Oakland to Salt Lake City was 592 miles, and it took 180 minutes. The flight from Denver to Salt Lake was 372 miles, and took 124 minutes. On which flight were you traveling the fastest? Okay, so for both these, we're going to Salt Lake City. So let's look at Oakland first. So good old Oaktown, it took 592 miles to go in 180 minutes. So how many miles? Let's set some more space up here. How many miles is this in 1 minute? Well, we'll divide both these by 180. And how many miles is that then? So that's 3.29 miles, rounded, in 1 minute. Well, what about from old Denver? Old John Denver. All right, well, that was 372 miles in 124 minutes. So we'll compare this once again to 1 minute. And how did we do that? Well, we divided 124 by 124. So 372 divided by 124. Oh, 24. It's just 3? 3 miles in 1 minute. So on which flight were you traveling the fastest?
The Denver flight.
Oakland. Yeah, because you're going a little bit more miles every 1 minute. Okay. An 11-ounce can of condensed soup, which is so yummy. Add 1 can of water. I don't know if they said that. Cost $1.45. A 20-ounce can, ready to serve soup, costs $1.29, $1.29. Which can of soup has the best price per ounce? All right. Well, let's look at the condensed. Condensed is 11 ounces at $1.45 for 1 ounce, right? 11 ounces, rather. Well, so there's something, I guess they did have to put that, add 1 can of water, right? Yeah, because you have to add the water, which increases the amount of ounces, right? So how many ounces is it for $1.45? So yeah, that is 22 ounces for $1.45. So what would this be in terms of dollars for 1 ounce? Well, we'll divide both these by 22, right? So $1.45 divided by 22, $0 and how many cents? So I rounded to the nearest penny right there. So that's condensed. What about ready to serve? This can has 20 ounces. Nothing needed to add for $1.29. Well, how much would this be for 1 ounce? Well, once again, we're dividing both of these by 20 this time. So $1.29 divided by 20. How many dollars is that? So yeah, we have to change this because they're pretty close to each other. So it looks like the condensed milk is going to cost a little bit more for every 1 ounce. Okay, whereas the ready to serve is just a little bit cheaper than the condensed. So 4th of July, the hardware store has 19 cents for 1 sparkler. And now the stand though has four for 85 cents. So 4 sparklers for 85 cents. So which is cheaper? Well, let's compare this to 1 sparkler. So we'll divide this by 4. And what is that?
21.25.
Very good. Cents for 1 sparkler. So where would you purchase your sparklers? Well, hopefully from the hardware store, because there's a little bit cheaper
What about the
per
drugstore?
sparkler.